Hi students, in this lecture I will discuss hydrogen spectrum. There are 4 points for your MCQ. One is hydrogen spectrum is atomic spectrum. Second, hydrogen spectrum is emission spectrum. And hydrogen spectrum is line spectrum, and hydrogen spectrum verified to Bohr's atomic model. Write down this term. Listen, hydrogen's topic is hydrogen spectrum. It is atomic spectrum, it is line spectrum, it is emission spectrum, and it is verification of Bohr's atomic model. Now, I will discuss concept of hydrogen spectrum. Look at the board. When energy is supplied to hydrogen gas, then gaseous molecules converts into atom. Again I am repeating, when energy is supplied to hydrogen gas, then gaseous molecule converts into atomic hydrogen. Now we have atoms of hydrogen. And when energy is supplied to atomic hydrogen, then different atoms of hydrogen absorb different energy, and electron jumps from lower orbit to higher orbit. When electron present in first orbit of hydrogen, it is called a stable state, called first energy level means ground state, a stable state. When it jumps from first orbit to higher orbits, then it is called excited electron, and it is in unstable. When energy is supplied, stop, then excited electron return towards the ground state. In doing, it emits energy and gives various spectral line, is known as hydrogen spectrum. Look at the board. Hydrogen gas supplied energy convert into atomic hydrogen. Different atoms of hydrogen absorb different energy, and its electron, that means electron of atomic hydrogen, jumps different excited state, that means first excited state means second orbit, second excited means third orbit. It's depend upon how much energy absorbed, and excited electron, excited state is called unstable state. When energy supplied is stopped, then excited electrons, all excited electrons, first excited, second excited, third excited, return towards the ground state. So when excited electron return towards the ground state, in doing, it emits energy. When electron falls from excited to ground state, excited to first orbit, in doing, it emits energy and gives various spectral line, is called hydrogen spectrum. Next, write down. Next, There are 6 series of hydrogen spectrum. Listen carefully for objective questions. There are 6 series. Number 1, Lyman series. And for Lyman series, N1 always 1. If in your mind it is arises what is N1, I will discuss in next section. Ki N1 is 1, lower orbit number, and N2 is 2, 3, 4, 5. Lyman series means when electron falls from any orbits, that means second, third, fourth, ... infinite. Electron don't fall from any higher orbit to ground state. It is called Lyman. I am repeating. When electron fall from second orbit to first orbit, called Lyman. Third orbit to first orbit. Third orbit to first orbit. First orbit also called ground state. So when third to first, Lyman series. Fourth orbit to first orbit, Lyman series. Always keep in mind, for Lyman series, N1 is 1 and N2 is 2, 3, 4, 5, ... infinite. That means any higher orbits to ground state, any higher orbits to first orbit, called Lyman series. Now, second name is Balmer series. And Balmer means when N1 is 2, and when N1 is 2, then N2 is 3, 4, 5. It means when electron falls from higher orbit to second orbit, third to second, Balmer, fourth orbit to second, Balmer, fifth orbit to second, Balmer, sixth orbit to second, Balmer. And one more thing, the second orbit means first excited state, not first orbit, first excited state. First orbit means ground state, second orbit, first excited state. Second, third, fourth, all are excited states, but second is first excited. Third series, Paschen, N1 is 3 and N2 is 4, 5, 6. That means when electrons fall from fourth orbit to third orbit, Paschen. Fifth orbit to third orbit, Paschen. Sixth orbit to third orbit, Paschen. Fourth series, bracket. And in bracket, N1 is equal to 4, N2 is equal to 5, 6, 7. And hence, when electron fifth orbit to fourth orbit falls from fifth to fourth, then name of series is bracket. Seventh orbit to fourth orbit, bracket. Infinite to fourth orbit, bracket. Number 5, Pfund series. When electron don't fall from higher orbit to fifth orbit. That means for Pfund series, N1 is 1. Sorry, for Pfund series, N1 is 5 and N2 is 6, 7, 8, ... infinite. When electron fall from infinite to fifth orbit, name of series Pfund series. When seventh orbit to fifth orbit, Pfund series. Sixth orbit to fifth orbit, Pfund series. And last and new series is Hamphrey. And in Hamphrey series, N1 is equal to 6, N2 is equal to 7, 8, 9, ... infinite. That means when electron fall from seventh orbit to sixth orbit, Hamphrey, infinite to 6, Hamphrey. Again, I am repeating all 6 series. Lyman, any orbit to first orbit. Always keep in mind, any orbit, second, third, fourth, to first orbit, to ground state, called Lyman. In Lyman series, always keep in mind, N1 is equal to 1 and N2 equal to 2, 3, 4, 5, ... infinite. Balmer, N is equal to 2. When electron falls from higher orbit to second orbit, called Balmer. When higher orbit to second orbit, called Balmer. Listen, N1 is equal to 2, N2, 3, 4, 5, dot, dot, infinite. Paschen series, when electron falls from higher orbit to third orbit, and third orbit called second excited state. That means when fourth to third, Paschen, fifth to third, Paschen. Bracket, some higher orbit to fourth orbit. Fourth orbit called third excited. Pfund series, some higher orbit to fifth orbit, and from some higher to fifth, that means 6 to 5th, Pfund. The N1 is equal to 5, always fixed for Pfund series, but N2 is equal to 6, 7, dot, 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 inside. Humphreys, some higher orbit to 6th orbit, that is for Humphreys series, N1 always 6 and N2 7, 8, 9, dot, 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 infinite. And these are name of series of hydrogen spectrum. I will explain one by one in diagram. Write down. Next, Rydberg equation. For numerical question based on hydrogen spectrum, used Rydberg equation, and Rydberg equation for hydrogen atom. 1 by lambda, where lambda is wavelength. RH is Rydberg constant, 1 by N1 square, that means lower orbit number. N1 is lower orbit number, N2 is higher orbit number. Again I am repeating, Rydberg equation. Rydberg equation is 1 by lambda is equal to RH, where RH is called Rydberg constant, and value of Rydberg constant, listen, in SI system 1.097, 10 to the power 7 meter per second, and 109737, 109737 cm inverse. It is value of Rydberg constant. N1 is lower orbit number, N2 is higher orbit number. For other 1 electron system, Rydberg equation is RH equal to, 1 by lambda is equal to RH into Z squared. Okay, why not Z square in this formula? Because for hydrogen Z is equal to 1. But other 1 electron system, that means for He plus, lithium plus plus, Z. For He plus, Z is equal to 2, and lithium plus plus, Z is equal to 3. It is Rydberg equation for other 1 electron system, and it is Rydberg equation for hydrogen atom. RH is Rydberg constant, value is given, and N1 lower orbit number, N2 higher orbit number. Always keep in mind, in any series, Lyman N1 fix 1, Balmer N1 fix 2, Paschen N1 fix 3, bracket N1 fix 4, Pfund N1 fix 5, and Humphreys N1 fix 6. Now I will discuss each and every series along with Rydberg equation. Along with Rydberg equation. Write down. The topic is Lyman series and definition of Lyman series. Listen carefully. When electron falls from some higher orbits to ground state. I am repeating, when electron falls from some higher orbit to ground state, that means first orbit, that is K orbit, then it is called Lyman series. Infinite to first, Lyman. 6th to first, Lyman. 5th to first, Lyman. 4th to first, Lyman. 3rd to first, Lyman. 2nd to first, Lyman. That means when electron fall from any orbit to first orbit, ground state, K orbit, then it is called Lyman, and Lyman series, N1 always fix 1. N1 always fix 1. Fix for all line. That means, listen, for first line, the first line of Lyman comes from second orbit. One objective question. First line of Lyman, because N1 is 1, the first line comes from second orbit. Second line comes from third orbit. Third line comes from fourth orbit. For MCQ, first line of Lyman comes from, and for first line, value of N2 is 2. And for second line, value of N2 is 3 in Lyman series, and N1 is fixed. N2 is 2, 3, 4, 5. But 2 for first line, 3 for second line, 4 for third line. Always keep in mind. Now, using Rydberg equation, 1 by lambda RH, 1 by N1 square, and N1 square is always 1 for Lyman series. The N1 is equal to 1 for Lyman series. So 1 by lambda RH, 1 by N1, 1 square minus 1 by N2, and N2 is depend upon question. Now, for longest wavelength, and longest wavelength means a smallest change in energy of first orbit, and for first orbit, value of delta E will be minimum when it subtract from second orbit. That means for longest lambda and shortest frequency, value of N2 just next orbit, 1 plus 1, that means second. If in a question it is given longest wavelength of Lyman series, longest wavelength of Lyman series, in case of longest wavelength for Lyman series, value of N2 is 2, so 1 by 1 square minus 1 by 2 square, value of RH already given, RH is Rydberg constant, 1.097 into 10 to the power 7 meter per second, and then I will calculate longest lambda. But in case of shortest lambda and longest frequency of any series, not only Lyman, Balmer, Paschen, bracket, Pfund, any series for for shortest lambda and longest frequency, value of N2 always be infinity. For any series. For any series, I am repeating, shortest lambda and longest frequency, N2 is equal to infinity. And for longest lambda, shortest frequency, N2 is equal to N1 plus 1. In Lyman, N1 is 1, but in case of Balmer, N1 2, and hence in case of longest lambda, shortest frequency, for Balmer series, N2 is equal to 2 plus 1 and is equal to 3. For Balmer, it is Lyman series, write down. Now, I will discuss about Balmer series. Balmer series. And listen carefully. When electron downfall from some higher orbit to second orbit, some higher to second, that means third to second, fourth to second, fifth orbit to second, seventh orbit to second, infinite to second, called Balmer series. From any orbit to second orbit, and second orbit also called first excited state. So when electron infinite to second, seventh to second, sixth to second, fifth to second, fourth to second, third orbit to second, it is called Balmer series. Clear? And for MCQ, listen carefully. First line of Balmer series. In Balmer series, N1 is fixed and N1 is fixed 2. In Balmer series, N1 fixed 2. Then first line comes from third orbit. Second line comes from fourth orbit. Third line comes from fifth orbit. And hence, for N1, for Balmer series, N1 2 and N2 is equal to 3, 4, 5, 6, infinity. It is Balmer, and by using Rydberg equation, we will calculate wavelength, frequency, wave number of any line of Balmer series 1 by lambda equation RH, 1 by n1 square in Balmer series, n1 always fixed 2, minus 1 by n2 square, and n2 value depend upon question. When longest lambda value of n2 always n1 plus 1. In Balmer series, n1 is 2, and hence for longest lambda, shortest frequency n2 is equal to 2 plus 1, 3, and for shortest lambda and longest frequency for any series, n2 is equal to infinite. Why infinite? Because energy change of an orbit in infinite orbit gives maximum value, and when energy will be maximum, delta E equal to hc by lambda. So when energy maximum, H constant, C constant, and upon lambda, that means energy inversely proportional to lambda. When energy will be maximum, lambda will be minimum. When E equal to H nu and frequency directly proportional to energy, so for longest frequency, n to infinite, for shortest lambda, n to infinite, because nu is equal to C by lambda, frequency and lambda. Lambda is, frequency is inversely proportional to wavelength. It is Balmer series. Now I will discuss third Paschen series. First, Paschen series. Listen, when electron downfall from some higher orbit to third orbit, and listen, third orbit means second excited state. Third orbit means second excited. Infinite to third orbit, Paschen series. 8th orbit to third, Paschen. 7th to third, 6th to third, 5th to third, 4th to third. It is called Paschen. That is for Paschen series. N1 is always fixed 3. N1 always 3. And N2, when N1 is 3, then N2 will be 4, 5, 6, 7, dot, dot, dot. But for objective question, if in a question it is given the first line of Paschen series comes from value 4, 5, 6, 7, answer will be 4, because in Paschen series, N1 is fixed 3, and first line comes from 4th orbit, second line comes from 5th orbit, third line comes from 6th orbit. And by using Rydberg equation, we can calculate wavelength, frequency, wave number of any line, 1 by lambda, RH. RH is constant. And for Paschen, 1 by n1 square, n1 is fixed for Paschen, the 3 square, minus 1 by n2 square. And we know that for longest lambda, shortest frequency, n2 is equal to n1 plus 1. The for Paschen series, 3 plus 1, 4. And for shortest wavelength and longest frequency for any series, n2 is equal to infinite. Now I will discuss fourth series named bracket series. Write down fast. Bracket. In bracket series, listen, same. When electron downfall from higher orbit to 4th orbit, higher orbit to 4th orbit, and 4th orbit means third excited state. When electron infinite to 4th, 8th to 4th, 7th to 4th, 6th to 4th, 5th to 4th, and it is called bracket series. For bracket series, N1 is equal to 4, fixed for all spectral line. Always keep in mind, bracket series N1 4. And N2 is equal to 5, 6, 7, dot, 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 infinite. Listen, first line of bracket series comes from 5th orbit. That means for first line of bracket, in bracket N1 is equal to 4, the first line comes from 5th orbit, the N2 is equal to 5, 6, 7, all are value of N2 for bracket. But for first line, value of N2 will be 5, for second line, value of N2 will be 6. By using Rydberg equation, we can calculate wavelength, frequency, wave number of all spectral line 1 by lambda RH Rydberg constant, and 1 by n1 square in bracket series. N1 is always 4 square minus 1 by n2 square, and n2 depends upon question. I am repeating, for longest wavelength n2, n1 plus 1, 4 plus 1, 5. Shortest frequency n1 plus 1, 4 plus 1, 5. Longest frequency n2 always infinity. Shortest lambda n2 always infinity, and also frequency equal to c by lambda. When I will calculate lambda, then it is also be frequency c by lambda. C is velocity of light, and wave number is 1 by lambda is also called wave number. Reciprocal of wavelength is called wave number. Now I will discuss fifth series named Pfund series. Pfund, same term. When electron downfall from some higher orbit to fifth orbit, downfall from higher orbit to fifth orbit, that means infinite to fifth, 8 to fifth, 7 to fifth, 6 to fifth, all are called Pfund. And for Pfund series, N1 always fix 5. N1 always fix 5. N2 is equal to 6, 7, 8, dot, dot, infinite. But for objective question, listen carefully. N1 5, fix for Pfund series. First line of Pfund series, first line. The first line comes from 6th orbit. If in a question, the value of orbit number for first line of Pfund series, the answer will be 6. Second line of Pfund series, answer will be 7, because for Pfund series, N1 is fixed 5th. N1 is fixed 5. The 6 to 5, first line, 7 to 5, second line, 8 to 5, third line. Clear? And by using Rydberg equation, we can calculate wavelength, wave number, frequency, and 1 by lambda RH. For Pfund series, 1 by n1 square, 5 square, because Pfund, n1 always fixed, and n2 depends upon question. And many times I discussed for highest frequency and shortest lambda, n2 always infinite. For highest wavelength, shortest frequency, n2 is equal to n1 plus 1. That means for Pfund, for longest lambda, shortest frequency, 5 plus 1 is equal to 6. Next, and last series, write down, last series is Hamphrey's. And same meaning, when electron downfall from some higher orbit to 6th orbit, downfall from higher orbit to 6th orbit, and 6th orbit means 5th excited state. That means n is equal to 6, infinite to 6, 8 to 6, 9 to 6, 7 to 6, all are Hamphrey's. For Hamphrey's, n1 is equal to 6. N1 equal to 6, and it is fixed for Hamphrey. N2 is equal to 7, 8, 9, dot, 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 infinite. By using Rydberg equation, we can calculate wavelength, frequency, wave number, 1 by lambda RH. We know that value of RH, 1.097 into 10 to the power 7 meter per second, 1 by n1 square. N1 is fixed for Pfund, and n1 is 6, 1 by 6 square minus 1 by n2 square. 1 by n2 square, and n2 square, and n2 depends upon question. Again I am repeating, for longest lambda, n2, n1 plus 1, 6. Shortest frequency, n2, n1 plus 1, 6 plus 1, 7. For longest frequency, n2 always infinity for any series, and hence Hamphrey series, n2 infinity for longest frequency, and shortest wavelength, n2 is equal to infinity. And these are name of series of hydrogen spectrum, Again, Lyman, Balmer, Paschen, Brackett, Pfund and Humphreys. Now, in one figure, look at the board. In one figure, when electron fall from, this is first orbit, any orbit to first orbit, Lyman series. But when electron any orbit to second, it is second orbit. Any orbit to first, ground state called Lyman. Any orbit to second, that means first excited state called Balmer. From higher orbit to third orbit, that means second excited state, Paschen. Some higher orbit to fourth orbit, that means third excited state called Brackett. Some higher orbit to fifth orbit, some higher to fifth, Pfund, and some higher orbit to sixth orbit called Humphreys. Always keep in mind, again I am repeating, Lyman series N11, N2, 2, 3, 4, 5. Balmer N1, 2, fix, N2, 3, 4, 5, dot, dot. Paschen N1 fix, 3, N2, 4, 5, 6, dot, 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 infinite. Bracket N1 fix, 4, N2, 5, 6, 7, dot, 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 infinite. Pfund N1 fix, 5, N2, 6, 7, dot, 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 infinite. Humphreys N1 fix, 6, and N2, 7, dot, 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 infinite. But some objective question, first line of Lyman series, the first line comes from second orbit, n equal to 2. If in a question, third line of Balmer series, third line, in Balmer series, N1 is 2, N1 is 2 and it is fixed. The N1, 2 and third line, first line third orbit, second line fourth and third line will be, third line from fifth orbit, the third line of Balmer comes from fifth orbit, answer will be n equal to 5. And in case of Paschen, fourth line of Paschen series, in Paschen N1 fix 3, first line fourth orbit, second line fifth orbit, third line sixth orbit and fourth line comes from seventh orbit. Clear? Now, I will calculate number of spectral lines, calculation of number of spectral lines in nature of Lyman series is ultraviolet. Listen for objective question. Lyman series ultraviolet. Balmer series and only Balmer series visible. Paschen, Brackett are infrared. Pfund, Humphreys are far infrared and it is depend upon wavelength. Again I am repeating, Lyman series ultraviolet, Balmer visible, Paschen, Brackett infrared and Pfund, Humphreys are far infrared. But right now I will calculate number of spectral line for objective question and most important for competitive examination, most important number of spectral line. Calculation of number of spectral line, case first. When an electron jumps from higher orbit to ground state, always keep in mind, this formula only applicable for from higher orbit to first orbit, ground state. I am repeating, only applicable when electron jump from nth orbit to ground state. Number of spectral line n, and n is nth orbit. The n into n minus 1 dividing by 2. One question, and this formula only applicable when electron jumps from higher orbit to ground state. That means ground state means lowest energy state when electron fall from higher to first orbit. Then number of spectral line is equal to n into n minus 1 dividing by 2. One question, calculate number of spectral line when an electron fall from fifth orbit to first orbit. Fifth orbit to first orbit. Fifth to first. Answer will be 5, क्योंकि फिफ्थ ऑर्बिट into 5 minus 1, the 5 into 5 minus 1, the 5 minus 1, 4, 5 into 4, 20, and 20 by 2 is equal to 10. If in your mind it arises the fifth orbit to first orbit, why 10 number of lines, then look at the board. Look at board. Explanation of the formula. When fifth orbit to it is first orbit, second, third, fourth, and 5 orbit number. When electron falls from fifth orbit to first orbit, look at both fifth to first, one line. When electron 5 to 1, but when electron falls from 5 to 2, 5 to 3, and 5 to 4. How much lines? There are 4 lines. Clear? But answer is 10. How 10? Look at board. When electron 5th to 4th, it is also called excited electron, and hence this electron also jumps, falls from 4th to 1st, 4th to 2nd, and 4th to 3rd. And when electron in third orbit, then also third to first, third to second, and this second orbit electron also falls to first. Now, look at board. 4 plus 3, 7 plus 2, 9 plus 1, 10, and hence total line is equal to 4 plus 3 plus 2 plus 1, and it is equal to 10. Clear? And hence formula is n into n minus 1 dividing by 2. But when electron falls to first orbit, this formula only applicable when electron higher orbit to first orbit. Next, second, when an electron jump from N2 orbit to N1 orbit, and N1 is not ground state, N1 may be 2, 3, 4, 5. Then what will be number of a spectral line? Number of a spectral line is equal to N2 minus N1 into N2 minus N1 plus 1 dividing by 2. This formula applicable for when electron jumps from higher orbit to any orbit when N1 greater than 1. Then calculate one question. Calculate number of a spectral line when an electron jumps from 7th orbit to 2nd orbit. 7th to 2nd. The N2, 7, N1 2nd, N2, 7, N1 2nd, 2, and plus 1. The 7 minus 2, 5. 7 plus 1, 8 minus 2. Sorry. 8 minus 2, 6. The 5 into 6 by 2, and it will be 15 line. And explanation of the question. Listen. 7 to 2, 3, 4, 5, 6. 6 to 2, 3, 4, 5. 5 to 2, 3, 4, 4 to 4 to 3, 2, and 3 to 2. That means number of line 5 plus 4 plus 3 plus 2 plus 1, and it is equal to 15. Clear? Now, this is concept and questions based on hydrogen spectrum. And in last, always keep in mind for Lyman series is ultraviolet, Balmer series visible, Paschen and bracket series infrared, and Pfund and Hamphrey are far infrared.